In this really quick lecture here, we are going to focus our attention on one specific type of triangle, isosceles triangles, obviously. And just as a brief review, because we talked a little bit about isosceles triangles when we were classifying triangles, but when we have an isosceles triangle, we have a triangle that has at least two congruent sides, but to be honest, more often than not, we're just dealing with two congruent sides, because if it has three, it's an equilateral, and we kind of deal with properties from that point of view. But here, we're going to be dealing with isosceles triangles, and they have just two congruent sides, that is. So in this particular triangle here, triangle ABC, remember, it may look isosceles, but don't treat it as isosceles until you know it's isosceles. So right now, we can't say for certain that it is until I put some congruence marks on there. Not very well drawn, but they are congruence marks. Or you could also get the same information kind of written out as side AB is congruent to side BC. Either way, that would then indicate that you have two congruent sides, which would make it an isosceles triangle. Now, I think we alluded to this when we were talking about them talking about isosceles triangles in the classification lesson, but obviously, by definition, an isosceles triangle has two congruent sides. And just as a reminder that angle B, in this case, because it's formed by the congruent side, is the vertex angle. And angles A and C are the base angles, but not because they are on the bottom. We want to break ourselves of the habit of thinking base means bottom in this particular case. So we have the vertex angle B, and we've got the base angles A and C. And I believe we alluded to the idea that, well, when we know we have two congruent sides, as we do here, do we have anything else that might be congruent? And that anything else is going to be our angles, our base angles. And when we have an isosceles triangle, and I'll get the notes down in just a sec, the slider down in just a second there at the screen rather. The side angle C, base angle C, is opposite side AB. Opposite mean when you think opposite, think opens up to. And side angle A is opposite side BC. Well, since this relationship is happening, side AB is congruent to side BC, the angles opposite them are also going to be congruent. And so if two sides of a triangle are congruent, then the angles opposite those sides are also going to be congruent. Pretty simple, straightforward idea. Nothing too complex math-wise, really. And it is one that, when you look at it, it will be not one that you have to be like, oh, I guess I can see that. No, it should be pretty obvious that two congruent sides should lead to two congruent angles. That's going to be how we set up and solve some math problems as a result of this. And what we're going to look at is say, all right, well, I'm going to give you two problems right now, and I want you to do is hit pause on the recording and find the measures of those particular things. Now, these two problems here are separate. So the green problem, if the measure of angle B is 30, find the measure of angle C. So I'm giving you the vertex angle, and I want you to find one of the base angles in the green problem. In the red, if the measure of angle C is 80, find the measure of angle B. I'm giving you one of the base angles. I want you to find the vertex angle. So take a minute right now, hit pause, take a minute or so to solve those, and then I'll walk through them real quick. All right, so hopefully you've had a chance to give these a try. The math behind this is not hard. This is not going to be super complex math that we're doing. We'll take the green one first, and if we have the vertex angle like we do in that green problem, we have the measure of angle B, and we know it's 30 degrees, and we know that all the angles in a triangle add up to 180, it's a pretty straightforward approach to find the measure of angle C, one of the base angles. We're going to take and subtract 180, or subtract 30 from 180 and divide by 2. Now, what I have right here, perfectly acceptable for how you should show work. I don't need you I don't need to see the 2x plus 30 equals 180 and then subtract 30 from both sides and then divide by 2 like we did in algebra class. This is still communicating that, yes, I know I'm going to take the vertex angle away and divide by 2, and that will give me one of the base angles. Totally acceptable. Likewise, if we're looking at we're looking to find the vertex angle if you are given the base angle, we're going to double the base angles and subtract that from 180, and that's fine right there. Again, that's this statement right here is something you can type in as is into a calculator and have the answer spit out. You write that out, I'm going to trust that you can do 80 times 2 and get 160, right? I wanted to know the vertex angle if the base angle is 80. That's communicating to me that you know that the base angles are congruent, that you know all the angles in a triangle add up to 180, and I saw where your answer came from. Very easy to communicate that understanding. Just a bit of advice after a few years of teaching this, make sure that make sure you're doing the right thing with the right information. What I've seen some people do, and what I mean by that is what the mistake I've seen people make is if they're given the vertex angle, as you were in the green problem here, I've seen some people take the vertex angle, double it, and then subtract it from 180. Or I've seen them, subtract one of the base angles and divide it by 2. I've seen people mix and match what they should be doing. So just recognize, and if you need a sketch, if you're not given one and the sketch helps, create one. That might be helpful, right? But the math, while not difficult, can get flip-flopped if you're not certain what you have for information. So just make sure that we shouldn't ever be doubling a vertex angle, and that sort of thing, and we shouldn't be having a base angle. So just make sure you understand what information you have to understand which relatively straightforward process you have to do to find a missing angle. All right. So that's pretty much it. That's the one thing that's pretty specific to isosceles triangles, that when you have two congruent sides, you do have congruent angles as well, and as such, you can use that to set up a problem and to solve. This type of problem will be fair game on our next summative, but I really do believe that if you can wrap your head around both the triangle sum conjecture, that all the angles add up to 180, and that all isosceles triangles have two congruent sides and therefore two congruent angles, really not the end of the world to work on it. All right? Please let me know if you have any questions, and I hope this helped.